session on industrial cybersecurity, raising our standards, and thanks for joining us today. Let's start by familiarizing yourself with the webinar tool. Take a look around for the chat and tell us where you're located. There's some housekeeping things to be aware of as well. We've got some upcoming dates for future events, such as the IIoT World's Digital Manufacturing Day coming on December the 8th. That's December 8th, 2021. Registration is open now. We're taking questions at the conclusion of this session, so please post those to the chat. This track will run for 55 minutes and you'll be out of here on time. It wouldn't be possible to run this virtual conference without our sponsors. So thank you to all our sponsors: Siemens, Fortinet, the Trusted Computing Group, Verve, Trend Micro, Atlas, Keyfactor, Schneider Electric, and the Building Cybersecurity Organization. And special thanks to TCG, the Trusted Computing Group, for sponsoring this session. Before we get into it, I'd like to tell you a little bit more about IIoT World. IIoT World is the leading authority on industrial IoT. IIoT World is a digital media outlet bringing the latest industrial Internet of Things, virtual conferences, and content to a global community of 279,000 decision makers and influencers like yourselves. IIoT World focuses on delivering daily insights on the IIoT, artificial intelligence, augmented reality, predictive analytics, digital disruption, autonomous cars, cybersecurity, machine learning, and smart cities. Well, with the housekeeping out of the way, I'd like to introduce our topic and speakers. Our goal for this session is to help you find out more about how TCG standards can be implemented today to provide increased security and protection from an unauthorized industrial security access and cybersecurity issues like that. It doesn't take an engineer to appreciate persistent warnings of the coming cyber Pearl Harbor targeting automated exploits that run critical infrastructures. There have been more zero-day exploits used in the wild in 2021 than any other year. In a recent study of 1,000 IT professionals, 83% reported some form of firmware security issue. And it's 98% of cyber attacks worldwide are involving social engineering methods. So, you know, the hackers are employing many methods, including something we'll be talking about later, the Shodan search engine, to worm their way into sensitive industrial control systems, often targeting automation that's running vital infrastructure, including the power grids, public water systems, oil and gas infrastructure, pipelines, refineries, depots, transportation systems, and whatnot. There's a whole tidal wave of connectivity that's being run deeper and deeper into automation to improve operating efficiency and reliability. And for this reason, industrial automation networks are in dire need of improved security. So fortunately, we've got a standard means now for frustrating these attacks on these systems by securely segmenting communications on top of standard IP protocols. And we're going to find out more about how TCG standards can be implemented today to provide that increased security. So I'd like to now welcome our speakers. Our first panelist is a member of the Security Area Directorate on the Internet Engineering Task Force and a co-chair of the Industrial IoT Security Work Group in the International Society for Automation. He's previously participated in other networking and security standards groups, such as the Industrial Internet Consortium, Open Group, and OASIS. He's the author of several IETF, TCG, and IIC standards and published papers, an inventor or co-inventor on 48 issued US and industrial and international patents, and we're delighted to have him here today. Please welcome Steve Hanna.
Hello,
Steve. Our next panelist has been part of TCG, the Trusted Computing Group, from its inception and has helped drive acceptance of TPM products for security in EMEA and many parts of AP. As an engineer in both IBM and Lenovo for nearly 25 years, his broad experience enabled him to assist thousands of customers to digitally transform their environments using Lenovo technology. Let's give a warm welcome to Thorsten Stremlau. Hello, Thorsten.
Hey, hello, everyone.
And our final panelist for this session is one of the founding members of the Security and Privacy Research and Engineering team in Microsoft Research, where he and his team have spent most of the last 10 years focused on advances in trusted computing and system security. His most recent work has been on the Device Identifier Composition Engine specification, known as DICE. And he had worked previously representing Microsoft on TCG efforts, including various specifications in supply chain, and he chaired the attestation and DICE work groups, and was also responsible for the development of the TPM 2.0 reference implementation, which I'm sure a lot of you are familiar with. He was also responsible for Microsoft partner enablement of TPM 2.0. Please join me in welcoming Dennis Mattoon. Thank you. Hi, Dennis.
Hey, hello.
And my name is Graham Bennett. I'm a technical writer working primarily in enterprise space and a member of Vancouver School Board's Internet Advisory Council and the former editor of the security-focused Microsoft TechNet Flash newsletter and your moderator for this session. So let's see how we're doing here with our timing. We've got some questions for our panelists. And part of the first thing that we'll be talking about is the problem that existing automation protocols have, in that they have little to no communication security built into automation. So we're going to look at what to do to frustrate attacks on these automated systems. Let's look at the standards that IoT customers should be looking at and what they're all about. Steve, can you please get us started here with a look at a kind of a high level about why industrial networks are in such dire need of improved security? We've got 3 minutes to talk about that.
Yes, I'm happy to do that. If we could flip to the next slide, I have a few illustrations that I think will show us, and it's good to tell, but it's good to show at the same time. So this slide shows a typical industrial network, multiple levels, the field level, control, supervisory, and the plant level. So that is, I'm sure, something that's familiar to all of you, this classical ICS control architecture. What industrial IoT really adds is cloud intelligence. And that intelligence can be introduced at multiple levels in the architecture. It can come in at the field level with edge computing. It can come in at the supervisory level with some greater analysis capability, or at the plant level as well to improve productivity. But the essential difference between traditional industrial networking and industrial IoT is the addition of this cloud intelligence. And with the addition of that cloud intelligence come risks. If we hit the next slide, we will see some of the risks that have been introduced and some of the attacks that have taken place over the last few years. Back to the granddaddy of attacks, Stuxnet. Now, these attacks have proceeded through a cyber attack on a German steel mill, which caused significant equipment damage, onto a attack, actually 2 sets of attacks against the Ukrainian power grid, which were cyber attacks. We know quite a bit about how those attacks were performed, and they did come in through the internet. And finally, to the Triton malware, which, most worrying, shut down safety instrumented systems in a gas pipeline. So we have these examples of what can go wrong if attackers can get through your defenses, and whether they come from the cloud or from the internet in general, the attacks and the problems are the same. And on our next slide, I talk a little bit more about what those are and why you want stronger industrial IoT security. So
if I may, Steve, may I jump ahead to introduce Thorsten to talk a little bit more about that point that we're on right now? Can I have Thorsten? talk to that from just this slide here?
Sure.
Sure, thank you. Thorsten, we've been talking about this idea of securely segmenting communications on top of standard IP protocols. What do we mean by that?
Well, I mean, we have to be very, very careful about you know, in the industrial IoT space, security, and Steve's done a fantastic job at setting all of this up, right? So back in September of 2020, we actually had the very, very first confirmed death in Germany by a hack that was done on a hospital subsystem. We actually just recently in the United States, 6 days ago, had another a poor little girl die when hackers hit another hospital subsystem. And so we're now, you know, what Steve's highlighted here are really, you know, the industrial attacks in terms of creating damage to systems, but we're also now seeing actual loss of life. And really being able to secure the communications network means that you need security at the hardware level before you go into the communications layer, right? So it's as in with anything in security, a layered approach is the thing that's just really, really important to that. And so by adding you know, TCG capabilities, like for example, a TPM that is able to provide attestation of the integrity of the communications platform and protect the encryption keys within the IP protocol with protected hardware keys, we're able to provide a whole different level of security in this space. And Dennis is going to cover, hopefully a little bit later on, you know, how we're also looking at then protecting the supply chain with TCG standards, so that things like the SolarWinds attack are prevented, right? Because those are also things that are growing in terms of attacking more and more software and communications protocols, right? So so I'm hoping that gives you a little bit of an insight into, I guess, first of all, how severe these attacks are getting, and then the importance of adopting and driving TCG standards into these different types of subsystems in order to provide the security both at hardware level and at the communications level.
Absolutely. And talking about Dennis, Dennis, perhaps you could tell us a little bit more. In my introductory little segment there, I mentioned what I characterized as the unnerving Shodan search engine. Can you tell us a little bit more about exactly what Shodan's all about and what makes it unnerving?
Sure. Shodan essentially is a search engine for internet connected devices. And that's any and all internet connected devices, everything from tiny little IoT devices up to complex systems, data centers, and as you mentioned, you know, maritime satellites, the IT network for a nuclear power plant, these kinds of things. And the reason people find it unnerving is exactly that reason, that everything connected to the internet could potentially show up here, and you know, that people would be made aware of it, and you know, because it has this capability, that's why people are worried. And the word, even though in the security community, we've acknowledged that security by obscurity isn't a strategy, except it's still in our nature to prefer to go unnoticed, right? We still don't want to be on anybody's radar, and something like Shodan makes that much more difficult. At its core, Shodan is essentially a war dialer. Our attendees of a certain age will remember what a war dialer is. You essentially set up a modem on a connected device with the terminal program. It goes through all of the phone numbers on a given prefix and goes and hunts for telephony devices. What computer system will answer? And in the old days, the more sophisticated ones would actually collect the banner. So when you connect to the device will respond and say, "Hey, we're the post office," and you log that number and you go about your dialing all the rest of the numbers on your list, and eventually you will revisit the post office and see if you can't access the device. That's exactly what Shodan is, except instead of a modem, instead of your Tandy 1800 and a 2400 baud modem, it's a bunch of cloud servers doing this on every conceivable IP address times 1,000 all the time. So
every kind of internet, Internet of
Things
right. Device, webcams, etc. Exactly. It's quite a an amazing tool, really, but also a very scary one from the IoT perspective. All right, well, let's now move on to kind of the big picture again. Let's talk, everyone, about the big risks, how we can mitigate them. Let's move back to you, Steve, and say, I see that TCG recently published a new document on securing industrial control systems with trusted computing. What can we learn from that, Steve?
Well, what we try to do in TCG, it's our responsibility as a bunch of security experts from different companies to develop standards like the trusted platform module, like DICE, which was mentioned earlier, for techniques and technologies that can be used to stop attacks. And that's all well and good to create those standards, and then they get built into systems, whether it's a laptop, a mobile phone, smart home device, or whatnot. But as they're built into things like industrial control systems, and many industrial control systems, such as PLCs, now include a TPM, we have to provide guidance for operators and security experts who are advising them on how to use those technologies. How do you use a trusted platform module? How should you use it in an industrial setting? And that's exactly what our new trusted TCG guidance for securing industrial control systems with TCG technology document does. In fact, if you search for that, or just go to our website, trustedcomputinggroup.org, you will see that document. You can download it. It's free, and it's in public review, in fact, until the 16th of this month. So we welcome your feedback on it.
Great, thank you very much, Steve. Thorsten, let's talk a little bit more about how the threat landscape has changed, in particular around what you were addressing earlier that we'll also get Dennis to talk more about, which is the supply chain and hardware-based attacks.
So especially, I mean, as digitization takes hold, right? And again, what we've seen is, and this is a blessing and also a curse at the same time. COVID has driven a tremendous acceleration of digital transformation, which means that many more companies are bringing their industrial systems online. Now, let's be very clear. There's a whole bunch of legacy in those industrial IoT systems that dates back sometimes, decades even from the first time. So now what we're seeing is a huge acceleration in digital transformation and companies needing to get access and better information out of their industrial IoT systems, right? But at the same time, what we're also seeing is this paradigm of this renewed focus from hackers on the soft spots. And Dennis mentioned it earlier on, as did Steve, right? So operating systems and the application layers are becoming more and more secure. Now, I'm not saying they're perfect, but they are becoming more secure. And so what hackers are now doing, and you need to look at it as a business, that's what hackers typically look at it for, is they're looking for those soft spots, right? And so they're looking specifically to those risks that Steve highlighted earlier on, and looking at new types of soft spots. And the soft spots that they're finding is, as I mentioned earlier on, for example, attacking at the supply chain. So how can I actually move and modify code before it's taken into operation, or how can I reuse somebody's update process that's already part of the supply chain? So we're actually seeing a huge increase in those types of attacks, both at a software level, like for example, SolarWinds, but there's many other examples, but also at a hardware level, right, where firmware modifications or even component changes are being done in the supply chain process before the device is even provisioned and brought under security control. Another really big aspect is, as we now look to expanding the industrial IoT segment, some of these devices are leaving the heavily invested and heavily secured network infrastructure that they were protected by before, right? If you take a look at, for example, a city's industrial IoT system that controls, I don't know, rubbish bin collections or garbage collection, right? These are now sensors and IIoT devices that are completely outside of the security perimeter that's being controlled by a typical factory. And they have new types of accesses as well, right? Maybe they're on public networks, maybe they're on, well, whatever. I mean, I've seen a lot, the Ethernet plug that's public that I can plug into in somebody's office that's actually the IoT control Ethernet system. Many things like that. So the attacks are increasing, the security perimeter is dissolving, and hackers are just looking for new types of approaches. And these are all things that keep Dennis, Steve, and I awake at night, which is why we're driving and we're writing these standards, right? Because we understand this is coming. We know the standards, or we know what we need to do. Well, we think we know what we need to do, but we, right, in order to address them, and the TCG standards such as DICE, the industrial IoT security, FIM-RIM, and many others serve specifically to help our adopters to implement this kind of security into their products and drive security as a whole.
So thank you, Thorsten. So Dennis, can we talk a little bit more? Is TPM a strong component in this solution? You're an expert in that area. How do we improve supply chain security? Is hardware the secret component? Is that the key component?
Well, I think it's a great starting point. Just like Thorsten said, it's such a huge space with so many different potential gaps that the answer really is to just identify the different stages and go identify the different places where weaknesses are. Yes, TPM is absolutely a solution for many kind of systems. It allows us to attempt to guarantee that we have trust in the systems that are responsible for producing different aspects of the supply chain, not just producing, but even managing the process of the supply chain. So in TCG, we tend to think about this problem in terms of stages. So the supply chain, the hardware supply chain anyway, I'm sure it's much more complex for other verticals, but everything from IP sourcing to design of the IC to EDA tools used to produce that, foundry, pick and place machines, the ODM, the OEM, all these different actors all have to be lined up and doing the right thing. And as Thorsten mentioned, if an attacker sees an opportunity at any one of these stages, that's an opportunity to affect not only that particular device, but the user of the device, the things that device eventually goes and ends up being responsible for managing. I mean, the Bloomberg article a couple of years ago is a great example of this. While the particular precise claims in that article are may or may not be completely well-founded, it doesn't change the feasibility of the attack. Every aspect of what is alleged is completely plausible today, and that should worry people, right? That's something that, again, like Thorsten said, keeps us up at night. TPMs in those systems in the supply that are responsible for managing the supply chain are hugely beneficial for these kinds of things, for building trust in those systems. And in all those systems for which a TPM is infeasible, would expand the BOM cost beyond a level we're comfortable with. TCG also provides solutions for those systems. DICE is a great example. All those different IoT systems that are small enough where perhaps a discrete part wouldn't be practical, there's an answer. Don't just think it's too small, it's no big deal. It's a big deal. If there's a spot that can be exploited, at their core, attackers are business people like anybody else, and if there's an advantage to be had, they will exploit that vulnerability.
Indeed. Let's talk a little bit more about, clearly this defense in depth approach. When we're talking about maintaining and updating embedded systems for industrial applications, the question of how to deliver that defense in depth is, we want to effectively protect against social engineering, zero-day flaws. The question that I have for all of our panelists here is, Are we going to be relying also on multi-factor authentication, or are we moving, to more like hardware security, or is there something else as well? Steve, can you give us your opinion on what's the right mix for people to be focusing on these days?
Yes, I'm happy to do that. I would say that there is no silver bullet, no one technology that if you deploy it in your industrial plant, that will magically make all of the security problems go away. It is, as you said, a defense in depth approach, a risk management approach that one must take. This is always true in cybersecurity. We have to think about what is the risk that we're trying to protect against, and what's the level of that risk? What would the impact be? What's the probability? These are things that are hard to determine in cybersecurity. And then what are the defenses that I can mount? Some are impractical. I saw a question in the chat regarding Windows. Can we remove Windows from our industrial plants? No, we can't. We have systems that have Windows installed on them, even old versions of Windows that have known vulnerabilities. And you may not be able to update that device, that system. This is legacy, and legacy is always with us in industrial systems because they have 20 or 30-year lifetimes. So we have to figure out how to manage around those legacy systems, manage around those known vulnerabilities, to design our systems to be resilient against those sorts of things. And that's what IEC 62443 is all about. How do you design an industrial system that is resilient, using things like zones and conduits, and having the connectors to those zones and conduits be highly secured, a state-of-the-art security there. Then you can have the soft middle that is the legacy systems.
Excellent. Well, thank you. That's good advice. Thank you. Let's talk to you, Thorsten, a little bit about what standards and developments do you think that our audience should be looking at as the kind of key starting places where they can get a good perspective on what's currently, the threat landscape for around cybersecurity?
So there's many, but looking at it right now from my experience in working with many of the industrial IoT developers, right? So again, I'm going to go a little bit back to what you mentioned, that defense in depth concept, right? So as Steve mentioned, we do have to deal with legacy, and that, by the way, is not going to go away anytime soon. But it really starts off, for example, just in the provisioning process, right? So how do I bring new devices on board and into my environment in a secure fashion, right? And there, by the way, there's a number of different things that are staple. And again, I'm just going to go back, but that TPM standard that we keep referring back to, I mean, that's what started the TCG off. That's really what we started off. That is probably one of the most important standards as a basic standard. I want to be very, very clear. But it has evolved. It has evolved over time, right? And so so I can use the TPM to do that secure provisioning. I know that platform is the one that I'm talking to. I can trust that platform, and all those other different types of things. And then, by the way, I can measure the integrity of that platform over time. So as I provision it, as I then add patches to it, as I do other things to it, and it changes over time, there are things that I can do. And lastly is I can store secrets in it. So anyway, TPM, really, really important standard as a basic standard. But as Dennis mentioned, there are also applications where that just doesn't make any sense, right? Either out of cost or out of size. Another very, very important standard from a TCG perspective would be that DICE standard. There are a couple of other ones that are fairly new, but that are also growing in importance, which is the FIM standard, the firmware integrity measurement standard that we're seeing. And this is basically a standard that defines how a IIoT subcomponent can measure all of the different subcomponents that are inside of it and measure the firmware integrity of it, right? So, for example, and I'm what if a hacker now managed to, not modify the core firmware of the device, but managed to subvert the network card firmware of the device, right? That in itself can be catastrophic, right? Or by the way, much easier, what if a hacker managed to subvert the touchpad or mouse input firmware of the device, right? So these are some of the things that we've got. Michelle, I am going to type those standards into the chat in just a second. I realize that I'm going a little bit fast on this one. Now, hand in hand with this, again, as you're looking to evolve, your standards, with the FIM standard, there's another standard called the RIM standard, the Reference Integrity Manifest, right? And this, by the way, defines how a reference document manifest that is now that you can measure up against to make sure that what you got and what you currently have and what you updated to is actually what you were meant to be doing, right? And again, as a basic standard, that's it. We have a couple of other ones, around cyber resilience that are coming up that are very important. I also have to say is our storage security standard is really important. That defines how you now protect storage subsystems that are embedded in IIoT systems, right? If you've got customer data, if you've got production data on there, how do you protect that against modification? How do you protect that against somebody encrypting it, ransomware, or how do you protect it, by using an authenticated encryption mechanism built into those devices? But Michelle, I am going to type those into the chat in just a second, but those would be, I guess, at a very high level. We have many more, and Steve is probably going, you forgot to mention this one, right? Yeah. but those from my perspective would be the most important to look at in the first bit. Steve, yeah, did I miss one? Okay, good.
So, Dennis, let's talk a little bit more about this aspect of hardware identity and attestation. Tell us a little bit more about how that actually, how that figures into it.
Thorsten couldn't have provided a better lead-in for that question, just because
Indeed.
It's essentially the basis for trust in systems. I mean, that sounds overbroad, but it's exactly true. So, in order to attempt to reason about systems on your network or what they're running, or the level of firmware on your network card, for example, on different components in your system, you need to start from some ground truth. I need to have a believable statement from a system that it is who they say they are. And that's essentially the pitch for hardware identity. Depending on the device you're talking about, hardware identity can take multiple forms. On a laptop or PC system, you probably have a TPM in there. The TPM has what's called an endorsement key. That's essentially the basis for identity in that integrated platform. This collection of devices has this overall identity. On smaller systems, like an IoT, you would have some kind of non-forgeable, non-reputable, an identifier with non-repudiation properties that allow you to identify the device and unequivocally know that that's the device you're talking to. That's typically in fuses or some kind of protected storage. And that's actually the basis for one of the other standards we've sort of touched on here today, and that's DICE. The DICE standard, for those systems that can't afford to include a discrete TPM, allow you to build on this hardware identity, this device secret that's statistically unique to that particular device, and allow you to build on that lowest level secret keys that can be used to identify the device to some kind of server infrastructure. And those keys are based on and then derived using measurements of the different firmware components. So we talk a lot about defense in depth and a layered approach to security. That's precisely how DICE works. And at the lowest level, you have this device secret. And as the device comes out of power on reset and starts up, different components are responsible for measuring and essentially establishing the identity of other components within that device. So when the device is ready to talk to the network, it now has a key that's based not only on the specific and very unique identity of this hardware, but the key also has mixed in the measurements of the firmware on that device as well. So if you identify that device and you sign, you can verify a message signed by that key, that tells you that device is who you think it is, and it's running precisely the software you think it should be. So that's the sort of combination of hardware identity and attestation that allows you to establish trust in that device. That DICE example is a smaller scale IoT example, but the exact same thing is true for TPM. So take everything I just said and apply that to TPMs and your laptop you're sitting in front of right now. Exact same process plays out all the time.
Got it. So we're getting a lot of fabulous questions coming in from the audience, so I want to make sure we have lots of time to address those. So in the next section, my next topic, let's just do it 2-minute chat about each of these topics. One of the things I want to talk about, it's an age-old dilemma in the security industry. When security is not failing, it can be difficult to convince management that additional expenditure is warranted. So let's talk a little bit about CapEx and convincing management that it's worth investing in something that doesn't necessarily show, you don't need it until you need it. So let's start with Steve. And can we build an industrial system today that will still be secure at the end of a long life cycle?
As I said, that's sort of a matter of managing legacy, because today's cutting edge will become state of the art within a couple of years, and a legacy 10 years after that, and it may have a 30-year lifetime. But to answer the question you specifically asked, more broadly, we have to talk to our management about what the long-term implications are of not doing the right thing from an industrial security standpoint. Yes, you can be purely reactive and wait for a regulatory order to come down, or wait for your systems get attacked and then your stock to take a nosedive. And potentially people to be injured, as well as lack of service to the public. But that's not the best approach. You want to get out in front of it, as with this new national security order from the White House, to be part of the coalition of the willing, so to speak, who are going forward in a proactive manner.
Yeah, absolutely. Thorsten, can you add on to that? What do you think the future of cybersecurity enhancements going to look like, and how do we pitch that to management?
So yeah, agree very much. I mean, looking at developments over 20, 30 years, it's difficult. As we said again, it's all about setting up rings so that as hacks evolve, maybe a device will go further down the ring or within the onion model and sink more and more into the core to be put behind other protection mechanisms. But yeah, I mean, looking at this, making sure that algorithms are protected against quantum compute is something that's absolutely vital within this space. But I'm seeing a lot of I guess light at the end of the tunnel right now, right? So looking, for example, and at getting all the information both upstream and downstream on the development of platforms, right? So that I can trust that software component that I got wasn't modified. And looking at, for example, and this is something that we are looking at very actively, is how we now use the TCG standards and technologies, for example, to add documentation at the entire life cycle of a product, including all of its subcomponents, right? So that I know that software that I received and that I'm using as part of my product, and that subcomponent at hardware level that I received as part of my product, that I have all of the documentation in place so that I can trust the vendor that's provided that to me and then in turn, I can integrate that, and my customer can trust me on that product as well, right? So that's it. So a short answer to that I just answered in a very, very long way is what we're seeing is a huge adoption of transparency in the security process that is going to be absolutely vital moving forward, both from an investment perspective and from a long-term viability into industrial IoT systems.
Mm-hmm. Dennis, we've got some of these questions coming in. There's one that I'd like you to have a crack at that's kind of talking a little bit about Windows platforms, which we touched on a little. I think we touched on this question a little bit earlier, but I think more discussion might be warranted here. The question from Tom Smartneck is, how important is segmenting Windows platforms, which seem to be most vulnerable in cybersecurity, from ICS to help isolate critical operational technology from outside intrusion? Of course, process systems are very reliant on Windows platforms in DCS systems, but isolating engineering workstations from the operational side as a first method. What's your thoughts on that topic, Dennis?
So I also saw a question in the chat that was sort of related about legacy and virtualization. It may not seem it, but they're kind of the same thing. This one of the approaches to security. One of those lists of properties of a secure device is compartmentalization, and that is ensuring that a failure in one area can't spill over and create a failure in another area. So it's going to sound like I'm defending my employer here, but I'm not actually. So trust me. But it's not as if Windows is a special case here. Windows is just the most targeted. And when people spend all their time looking for problems with one thing, it seems like that one thing has a lot of problems. That said, unfortunately, we can't get around the fact that we've got a lot of systems, especially in an industrial environment, running legacy stuff. And we also, with that comes an inability to just on a whim go and retire that legacy stuff. We have to keep it around. So it's really up to us to do our best job to, where we can't update and retire or fix these kinds of vulnerabilities. We need to fall back on those kinds of isolation mechanisms. So either something like virtualization, if that's a possibility, or compartmentalization, like physically isolating these systems where possible. And I know an approach some organizations take in isolating their IT and OT operations is to air gap everything. Yes, that introduces some complexity and some annoying kinds of things you have to do, but always user experience and security are at opposite ends of the spectrum. You want it super nice and easy? Well, good luck with the ramifications of those decisions, right? You want to make sure that this factory floor never gets taken over by some new and exotic botnet. It's gonna not be a great experience, except that's the trade-off we need to be willing to make, and cyber resiliency plays a big part of this as well. It's great to have that defense-minded attitude in terms of computer security, but we have to accept that these attacks will be successful. There is going to be another ransomware event somewhere, sometime. So recovery and the ability to continue operating in the face of these successful attacks is something that really is one of our focuses at TCG as well. Just because, again, it's great to have that defensive mindset, except you must also accept that these attacks will be successful. How do you get back online as quickly as possible?
Exactly. And that's going to take me to our final comments. I want to ask each of you kind of just for a quick 1-minute summary of what security professionals should start or stop doing. Steve, in 1 minute, anything you can recommend that security pros should start or stop doing?
Well, other than reading our guidance document, I think the most important thing is to educate yourself.
Yes.
To take some of the trainings that are out there, ISA has a great set of trainings on industrial cybersecurity, and you need to keep, shall we say, sharpening the knife. You need to keep improving your ability to respond and to explain to your management what's necessary. This is true in terms of our defenses also. We have to be always raising the bar in terms of defense because the attackers are always raising the bar in terms of offense.
Exactly. Thorsten, any thoughts on that topic?
To expand on what Steve said, I mean, looking at it really, any model, whether hardware or software, really think about implementing a zero trust model that requires each component of that chain, whatever that solution may be, to verify, attest, protect itself against hacks, right? It starts off, as I said, at the hardware layer, right, and have all of the subcomponents be able to do that. It then moves into the software layer, it then moves into the communications layer, it then moves into the infrastructure layer, right? So please, that would be my one thing in a minute summary, is make sure that you look at that defense in depth, at that layering that really starts at the IIoT hardware, and then you can expand back into the infrastructure.
Excellent. That's great. Dennis, we've got, again, as I mentioned earlier, we've got some great questions coming in. I'd like to, because we're at the time we should start our Q&A, let's jump right in there. And my question for you is from James Slora. How do we get engineers and IT to work together for secure implementations?
That's more of a people question than a technical question. I don't know. I think it's going to sound hokey, but there really needs to be a mutual respect. I know often in organizations those two are at odds, and that needs to stop. If you want to be able to, stop the FUD. That's a great suggestion in exactly this area. There is we need. So I'll just piggyback on what Thorsten said. You need to identify the gaps, those potential gaps, and start to think about this a little differently, and especially in terms of again, I'll go back to compartmentalization, because that's kind of what it is. Defense in depth and making sure those critical systems are isolated and the access is appropriate, and that's where IT and engineering comes in, because it's kind of IT's job to work the operational side to make sure things are configured and set up in a way that makes sense. But it's also engineering's job to take feedback where they can get it, and ensure that the construction of those systems is also sound, and they're using these kinds of zero trust principles and trusted computing principles to attempt to build trust in those systems that are managed by their IT organization. So it really does go both ways. And again, I'll continue to parrot the advice that we need to start thinking more about what happens when there is a compromise. Don't be caught off guard by this, right? You must expect these systems to be exploited if they're internet facing. And you need to develop a plan for how to recover. And I encourage everybody to check out the cyber resiliency work from TCG, but also, start with NIST 800-193, right? That's where this work really started. And it's important. So when your plant gets shut down because of ransomware, it'd be great to have that big red button to reset instead of having to go call the FBI to have them pay some ransom, right? So we never want to have that scenario.
We have a great question that came in from George Prokopos, forgive me, George, if I mispronounce your name, but from SPN. And it's a great question here. He says, as with firewalls, then IPS, then active asset queries, server, workstation, EDR, etc. All these things have slowly become acceptable. Do we see something like an agent running on PLCs becoming more acceptable, like Cybeats or Azure's IoT agent, but directly on industrial control system devices? And I think that's a really great question, and kind of future looking as well. Any comments from anyone? Maybe Steve?
Yes, absolutely. We need to make sure that real time is a consideration in any industrial control system. So we have to make sure that real time constraints are still maintained, but having and designing into the device security measures, both in hardware and in software, makes a lot of sense. We need to have these devices be self-healing, and that's what cyber resiliency is all about. And in order to do that, there needs to be security built in both at the hardware level, because you have to have that foundation, and then in software as well.
We have a question here from James Castle, who asks for our opinion on quantum resilient encryption ending ransomware, the potential for that to be a thing, as well as securing communications through the cloud from data theft. Any thoughts on that?
Well, if you don't mind me jumping in again, I will do so. So I would like to say that with respect to ransomware, I would say again, I think there is no single silver bullet, but quantum resistant cryptography certainly has a benefit, but primarily that benefit is to protect against quantum computing. So if we talk about that, potential for a practical quantum computer attack 10 years down the road, yes, that's a good defense against it, but it's not practical today. If we're thinking about quantum crypto, again, this is an over-the-horizon, option. So there's different kinds of quantum crypto, post-quantum crypto and quantum crypto. And anyway, I won't go into it any more than that, but just to say that what we need is solutions that work today, as well as plans for the future. And post-quantum is certainly part of that.
Indeed. Let's see, what else have we got here that are good questions? Here's a somewhat specific question from Lloyd Woods. And he asks, can we speak to, by utilizing an DMZ concept between a trusted zone and an untrusted zone, say enterprise IT, can that still apply to IIoT? So
I'm happy to jump in here again, unless someone else
Steve,
does.
go.
Having spent years studying these things, yes, absolutely. A DMZ and in general, the concept of network segmentation is absolutely essential in any industrial environment. You can't have uncontrolled flow from one zone to another. And it's not incompatible with IIoT and with cloud connectivity. You just have to make sure that you know exactly what's flowing and in what direction and to whom, and that you don't have unauthorized traffic coming through that DMZ or whatever checkpoint you use, whether that's a DMZ, a firewall, a VPN gateway, or the like. You want to make sure that only authorized users, only authorized destinations, only authorized traffic of exactly the right type is flowing through there, and you've got as many security controls in there as you can.
Indeed. I think we got time for one more question before we have to start wrapping up. But this one I think is great. It comes from Mike Callender, who asks, we've had our equipment reviewed by an industry specialists who provided engineering level guidance, which takes us so far. But is there some way we can build industrial security checking into our in-house testing? For example, perhaps using the Shodan platform to hunt our own equipment. And I think that's a very interesting approach, and I would be inclined to do that myself. Any thoughts?
So, this is again something that's really common. Obviously, on the one hand, is there's always multiple layers of implementation, right? On the one hand, you want to make sure that you get the user experience right, whatever the device is. So you'll probably while you go through engineering advice on how you best build the product, is at some stage you're going to have to put it through user experience testing to make sure that you didn't put an engineering interface on it and that no user can actually use it, right? Let me be very clear, right? But you know, a very, very commonplace right now is for dedicated software and hardware security review boards that are made up of multiple members within an engineering organization and within the actual organization to now review at the entire level, right? And then, by the way, if your solution has a cloud component, I would definitely pull in somebody who has specific knowledge, for example, on cloud security. So what we are seeing is in any part of it's not just an engineering design in terms of you need to use this CPU and this chip and this whatever and this board layout, but now also get somebody to do the full security review of the product and all of the interfaces that go along with it. And I guess given today's security skills market, it's hard to find those, but there are actually plenty of organizations that do that externally as well. It just depends on your budget, right? And on the product.
Well, that's all the time we have, folks. Apologies if we didn't get to your question. I'd like to thank our guests, the attendees, everyone who asked a question, and of course our sponsors. Thanks again to our speakers for their amazing insights and knowledge, and thanks again to the Trusted Computing Group for sponsoring the session. Reminder, we've recorded today's session. If you wish to access it, I recommend that you purchase an annual pass to IIoT World events. This will also provide you with access to IIoTday.com content, costs $99.99. Your support ensures that we have all this great content to share. Thanks for listening in. It's time to now move on to the next session. That is when, not if, strategies for responding when your OT network suffers a ransomware attack. Hope you all have a great day and a great conference. Thank you for attending.